Hello and welcome to a new video about my barbecue controller. Well, the case is ready, everything is fine. I can close it, there is the LED built in, everything is nice. I am concerned about the energy consumption. Okay, we have a battery powered device, and this battery, I want to measure how much voltage or how much current is drained. So actually there's the switch. If I turn it on, this is working pretty well. Then we should see the LED flashing. Yes, it's flashing. So it is transferring some data. There's also the LED of the nanolith. This is already something which we could optimize probably. But let's make a baseline. Okay, let's make a baseline and see how much milliamps we currently need. So the only thing I have to do, I think, is here, connect to here. Then we are at one side of the, oops, that does not work too good. Then we are at one side of the switch, and on the other side, there it's lit. But the LED was not flashing, right? Move it again. On. No. There is no LED flashing. We need around 50 milliamps for the 8 milliamps. But this must be the same, right? What if I turn it on? It's flashing. But if I'm short-circuiting it with the measurement device, it's not flashing. No. Probably we see a little bit too big measurement resistance here. What to do? Let's power supply this with. Let's hope this is enough then. Alright, batteries out. There are even standard batteries inside, so not because I want to use. So this is minus, this side is minus. So I'm going to connect this to minus here. Alright, this should fit. And plus, well, here I have to, for sure something full of the, come here, power, 2 volts, alright. So this should be minus, it's minus. Plus I will put here. Alright, plus, and here I need a connection from plus to here, milliamps, and here, ta-ta, something happening. Okay, go up with the voltage. Is it flashing? No, why not? Go up, now. Ooh! Alright, so we have around 76, 80 sometimes when we are sending. I think this will be when we are sending. Why are we sending all the time? Now it's always sending. Let's plug this in. What is it sending? The battery voltage. White is the battery voltage. Now it's red. White, all the time it's sending white. 100 and 0, 100 and 0, 100 and 0. I'm not sure why. Maybe I will go in with 4. Alright, now it looks stable. Let's say we have 4. Okay, 4 volts. Now it looks stable. I can measure. It's not sending. At 4 volts, we need 97.6 milliamps. take a note here. 4-volt supply, 97.6 milliamps, and when we're sanding, it was around 120, right? I call standard. And let's plug in a probe so that we can trigger sanding. There's a red, no, there's a blue one. Oh, why not? Just plug it in somewhere. Blue, here, grab it. Going up to 106 or something like that. Around 105, sanding. First measure, hardware measure. I'm using here now a DC-DC converter to go to 9 volts. Alright. Then I'm power supplying my Arduino, which is using a DC-DC converter to go to the internally used 5 volts. And this means I have 2 DC-DC converters in series. I really don't need this because every DC-DC converter has a certain efficiency, right? And so I waste efficiency because I'm using simply two of them. So what I'm going to do is I'm going to power supply the Arduino by the 5 volt, so that we don't have this second DC-DC converter. So I'm going to power supply this at 5 volt, and then it should be fine actually. Hot. Soldering iron is hot. Did you know that? I removed now the connection. Between V-in and plus. So I'm going to add a connection now between this pin, where I then power supply 5 volt, and the 5 volt pin. So this here will just make it look pretty. Right, and then we need cable, short cable. 5 volt pin. Of course, I have to adjust the voltage. When I do not want to destroy this thing, I have to adjust the voltage. I'm going to do this now. Turn it on. Batteries. Turn on. Right now we should have 9. I think I adjusted it to 9. I'm now going to adjust this to 5. 5 volt. Good. Adjusted it to 5 volt. Get out. I will put out the batteries again because I want to see immediately if something has been changed. So I am again using here minus. Yeah, good. Then with plus I'm going to go to here. Let's also measure how much this thing alone is draining. And here, yeah, I want to measure milliamps, thank you very much. Plug it in. This thing alone takes 0.2 milliamps. Alright. Now, let's mount this plate. Let's see if I'm destroying something. Let's mount this again. I'm measuring directly at the battery, actually, because I want to see how much I'm draining from the battery. I will find it afterwards. One screw is missing. I always suspected some lost screw. Find it afterwards, this screw. Does not really matter because I want to see if this is working now. Plug this in. Yeah. And now we should also operate. Yeah, it is flashing. It's already a big difference. Look at that. Huh? We are at 50 milliamps only. Yeah? Just by excluding the second DC-DC coupler, we are at 50. Yeah? Also take a note. Okay, this was a good measure. Before we were at 97, yeah? And now we are at 50. Let's plug the blue again and see how much we have when we are sending. This is actually working pretty nice. We have 49.8 without a second DC-DC converter. And around I saw 57, around 57 without sending. All right, this already looks much better. And now we can try to optimize this by software. This we'll do in next video, okay? Try to make it even better by sending those things to idle and so on, so that they are not constantly operating. Next video. To this time, thank you very much for listening. Goodbye.